All right, upper and lower bounds. So when you look at upper lower bounds, you're looking at if a number has already been rounded off to a certain amount, what could the smallest or greatest number be? Now, your upper bound generally isn't the biggest number it can be. Your upper bound is normally the limit beyond which you couldn't go, but it's normally a number bigger than what would have rounded down. So, for example, if I said the number 4,700 has been rounded to the nearest 100. Oh, running out of space, hold on. To the nearest 100. Now, they'll ask me they could ask me what is the upper and lower bound. So it's just a very simple, what is I'm going to call it LB and UB for the upper bound and lower bound. Okay, so that might be your question, something as simple as that. Well, if it's rounded to the nearest 100, whatever they're rounding to, so you take the number that they've rounded it off to, the 100, and you say, right, what is half of that? So half of 100 is 50, right? So I'm going to take my original number and I'm going to subtract 50 and I'm going to add 50. So 4,700 minus 50 would be 4,650. I'll then say that must be bigger than or equal to, because it could have been 4,650, because that would round up. By that being a 5 would round the 6 up to a 7, and that would definitely round up to 4,700. And you can either put a variable there, like an x, or you can put your 4,700 there, that's either or. And then less than, but not equal to, your 4,700 plus 50, which would be your 4,750. So that's the easiest way to do an upper and a lower bound, is to take whatever they're rounding it off to half that, and then add and subtract that number that you get, that half, from the number that they've told you been rounded off. Now, that's quite nice and simple when you're rounding off to the nearest 100, because the nearest 100 is easy to work off. But what if they say something like what am I doing? Let's say 2.35 rounded to the nearest second decimal place. Well, the second decimal place is your hundredths, right? So it's your hundredth column. I do exactly the same. I say, what's half of a hundredth? So I'm going to do the same thing. I'm going to take my hundredth position, and I'm going to say a half of 100th. And half of a 100th is the same as saying a half of my 0.01. I'm going to use decimals because that's decimals, rather than using a fraction, because it just makes it easier when you're actually working this out. Well, half of that, if I halve that or divide 2 into that, I'm going to get 0.0. This thing is frustrating me because it's so limited. Let me just try and move this out a bit. There we go. That should work better if I make it a bit wider. 0.05 is half of 100. Now I've done that wrong now because of this page annoying me. 0.005. That would be half of a hundredth, okay, which is 5 thousandths basically. And if I doubled that, if I times that by 2, it would get me back to my hundredth. I'm now going to take this amount, add it and subtract it. So I'm going to say, right, well then if I take my 2.35 plus 0.005 is going to be, subtract, what am I doing? subtract. So then I'd have put an extra 0 over there, borrow from the 5, make that a 4, that says 10. 10 minus 5 is 5, 4 minus nothing is 4, 3 minus nothing is 3, 2.345. And I'd say that then my, I'm just going to use a variable this time, my x is bigger than that, because remember, that's not necessarily my number, that 2.35. That's what the number was rounded off to. So that's why I like to use a variable rather than like I did earlier where I used the actual number. So I'd say my x is greater than or equal to 2.345 or less than, and remember on this side we don't put a line underneath because it has to be less than your 2.35 plus 0.005. And that's quite an easy one because that would just give you your 2.355, because again you could put a 0 there and just add it all up. That will give me my upper and lower bounds. Now that's quite an easy one. That's just straightforward solving upper and lower bounds of a number they've given you that they've said they've rounded off to. Now, what do you do when they put that into a problem? Like they might say, for example, let me just see. Here's a nice one. They've given me a rectangle, and they've said to me that my dimensions of the rectangle are, if I look at this, it's 3.61 centimeters at the top, and it's 2.57 centimeters across. And they've said the dimensions of this have been rounded off correct to 3 significant figures. So in other words, it's rounded off to my second decimal place, as we've just looked at in the example. And they've said, knowing this, they want the upper and lower bounds for each dimension. So we've got the length and we've got the width, right, of the rectangle. So for the length, I'm going to, again, I'm at the 100th point, so I've got to take 5 thousandths would be half of my 100th point. So I'm going to say that for my length, my upper bound and my lower bound are going to be my 3.61 plus minus 0.005. So I'm going to start with my 3.61 minus 0.005. So it's always to the digit immediately after the digit that we ended with over there. Again, make that a 0, borrow 1 from there, so that'll become a 0. 1 minus 10 minus 5 is 5. 0 minus 0 is 0. 6 minus nothing is 6. And 3 minus nothing is 3. So that's my lower bound. Why have I done my bounds the wrong way around? You're going to have to watch me today, Twyla. I've got a bit of a sinus headache and it's just messing my brain up. That's my lower bound. That's my upper bound. All right. Then I'm going to put that less than or equal to my length, in this case, which will be less than my upper bound, which will be my 3.61 plus 0.005, and that will give me my 3.615. And you can see the upper bound is actually the easy one because it's always just tacking a 5 on the end. That's pretty much all you're ever going to do for your upper bound is just slap a 5 after the last digit that you have in the number that they've given you. That's my upper and lower bound for my length. For my width, again, my lower bound and my upper bound for my width, I'm going to take my 2.57 minus my 0.005, put a 0 there, borrow 1 from the 7, 10 minus 5 is 5, 6 minus nothing 6, 5 minus nothing is 5, and 2 minus nothing stays 2. Great, less than or equal to my width, which is less than my 2.57 plus my 0.005. I seem to get myself all caught up in the corner here all the time. So that'll be 2.575. Once again, I've just slapped a 5 on the end of the 257. All right, so that's the first part of this question. This question had a part A, and the part A was just finding out those. So I'm quite happy now. I've got my lower bound and my upper bound of the width. I've got my lower bound and my upper bound of the length. I've done what they've asked. They then say in part B, they say for part B, I've got to find the upper and lower bounds of the area of the rectangle. Now, you know area is length times width. So then for the lower bound, I'm going to take my two lower bounds. I'm going to take the lower bound of the length times the lower bound of the width. So that would be 3.605 times 2.565, and that would give me an area of, let me just get my calculator quickly. Okay, where were we? 3.605 times 2.565 gives me an area of 9, and I'm just going to round this off because they've rounded off to 3 significant figures. I'm going to do the same, 9.25. That will be my lower bound area. My upper bound area would simply be my upper bound times my upper bound, which was my 3.615. Remember to put your units in centimeters squared. 3.615 times 2.575, and that would then give me an area of 3.615 times 2.575, 9.31 centimeters squared. So you can see what I do for the area. When they want the lower bound, I use the lower bound lengths. When they want the upper bound, I want the upper bound lengths. And that's basically the area. Write down the upper and lower bounds of the area correct to 3 significant figures. Okay, so this one they actually had, sorry, I've rounded up to 3 significant figures straight away in B. For B, they actually didn't want you rounding off, so you would have had the whole long decimal in B, but I'm just jumping a step. That's fine. The main thing is you understand it. But there are times where you've got to use the upper bound of one and the lower bound of another. So if I look at the questions like, for example, let me just go down. I'm just going to stretch my page down a bit lower, and these will come up in your things where you've got to divide. Anything where you've got to divide, you might want, I'm just going to get a new page. It'll just save me time. All right, so they might give you something like this. Let's just say A equals 5.6, B equals 24.1, C equals 145, and D equals 0.34. Each of these have been rounded to different places. This has been rounded to 1 decimal place. This has been rounded to 1 decimal place. This has been rounded to 3 significant figures. And this has been rounded to 2 decimal places. So that's what they've given us. Now, I'm going to take each one of these one at a time, and I'm going to work out the lower and upper bound. Now, obviously here for the lower bound and upper bound, I'm either going to add or subtract 0.05. Remember I said for the upper bound, we just slap a 5 at the end. So to do that, I had to add a 0.05. The same with B. I'm going to also add and subtract 0.05 there. For this 3 significant figures, my last significant figure is my units. So for this one, I'm going to add and subtract 0.5 because that's the next place value after that 5. And then for my 2 decimal places, I'm going to add and subtract 0.0 for the 3, a 0 for the 4, and then my 5 going in there so that I can slap a 5 on behind that 4 when I add. All right. What does that give me? That gives me, for a lower bound and an upper bound of, if I subtracted 0.05 from there, I'm going to get 5.55 from subtracting 0.05 from that, and adding it, I'm going to get 5.65. Can you also see between your upper and lower bound is exactly one whole unit of what you've rounded off to? I rounded off to 1 decimal place, and there's exactly 1 decimal place more on the upper bound than there is on the lower bound, because if I added 0.1 to my lower bound, I'd get 5.65. So whatever you're rounding off to, that'll also be the difference between your upper and your lower bound. Going on to then B, I'm going to get 24.05 if I subtract 0.05 from that, and 24.15 if I add 0.05. Three significant figures. I'm going to get 144.5 and 145.5 by adding or subtracting my 0.5. And then for my D, I'm going to get 0.335. Notice also, whatever your last digit is here, your lower bound, you'll subtract 1 from that. So you take 1 away from the 3. So you make it, instead of 3,4, you make it 3,3, and then just stick a 5 on the end. That's just the shortcut method of doing it. And then 0.345. There's your upper and lower bounds for each one of those. Now I'm going to show you that one of the questions they gave, which you'll see what I mean by you sometimes have to use the upper bound of one and the lower bound of the other. They said, find the upper and the lower bound of AB over CD. Well, for the upper bound, I need a bigger numerator and a smaller denominator, because with fractions, like if you take, for example, let's use 3 over 5 is less than 4 over 5 is less than 100 over 5. So the bigger the numerator gets, the bigger the sum gets, or the bigger the value of the digit. But if I take the numerator, I keep making the numerator bigger, I get smaller and smaller fractions. So if I take, for example, if I said 1 over 2 is bigger than 1 over 4, because a half is bigger than a quarter, which is bigger than 1 over 100. If you had to try and divide a pizza up between 2 people, you'll get big slices. But if you're going to try and divide it up between 100 people, there's just no point. You're going to have 100 very hungry people, because a pizza doesn't divide into 100 very nice. The pieces will be tiny. So what I've got to do for the lower bound is I've got to try and get for the lower bound, the smallest possible numerator and the biggest possible denominator. So for the lower bound of this, I'm going to use the smallest a that I can, which is my 5.55, times the smallest b, which is your 25.05, divided by the biggest possible numerator I can get, which is your c times d. So that will be the 145.5 times my 0.345. So I'm using the upper bounds of C and D. And then hopefully you have one of these calculators, because this is quite cool because it's got that fraction button there. And then I can just put everything in as a fraction, 5.55 times 24.05 at the top, go down to the bottom and do my 145.5 times my 0.345. So you can see I basically just made it all like one big long fraction, push my equal sign, and it's given me 2.659. I think I'm going to leave it as that. I'm going to leave it as 2.659. They don't tell me how many digits to round it off to, I don't think. Oh, they said to 3 significant figures. Okay, so 3 significant figures is what the question's asked for. So 3 significant figures means the first 3 figures, and because that was a 9, it'll round this up to a 6. So I need to make that 2.66, because if you remember, the number immediately after the 5 is a 9, bigger than 5, so it rounds up to 6, and 3 significant figures just means the first 3 non-zero digits, so it's just the 2, the 6, and then what would have been a 5. And then for your upper bound, you're going to do the opposite. Your upper bound, you want the biggest possible numerator, so I'm going to take the biggest values of A, or the upper bound of A, which is your 5.65, times your upper bound for B, which was 24.15, and then I'm going to divide that by the lower bounds of C and D. So I'm going to take 144.5 times 0.335, and then I'm going to go and do the same thing I did earlier. So I'm just going to use my fraction button, my good old fraction button. I'm going to go in there, and I'm going to type in my 5.65 times 24.15, go down to the bottom, 144.5 times 0.335. So there you can see I've put it all into the calculator exactly the way I've written it. I've typed it, and I get 2818. So 3 significant figures. So what's important then? Go 1, 2, 3. The third figure is that 1, but that's an 8, so it rounds it up to a 2. So then that'll be equals, where did my pen go? There she is, 2.82. Now, this number should be bigger than the previous one, and it is. 2.82 is bigger than 2.66. So there's my upper bound, there's my lower bound. So you do have to do some thinking with upper bounds and lower bounds. You've always got to make sure that the answer you're giving for upper bound will clearly be bigger than the answer for a lower bound. And it does become a little bit complicated when they start bringing in algebraic fractions. You've just got to try and keep your head about you. And just remember that if it's a fraction for an upper bound, biggest possible numerator, smallest possible denominator. For a lower bound, smallest possible numerator, biggest possible denominator. And that should be it. And I think that pretty much sums up upper bounds and lower bounds. I hope that's made it easier for you.